Quartic's multivariate data analysis application provides a cost-effective solution to improve batch performance, reduce waste by identifying root causes, and accelerate investigations. Coming into the MVDA application, I'll go through an example of improving batch yields through the seamless workflow from offline investigation to real-time monitoring to predictive modeling. First, I'll connect into the Quartic platform to pull in my contextualized batch data. For the selected recipe and process steps, this automatically pulls in the batches and my process parameters, including time series parameters like temperature, as well as my sample quality data for yield, bioburden, etc. Once I have all this data, I want to visually compare these batches to identify clusters of high-performing versus lower-performing batches. The MVDA tool transforms all my variables to 2, making it easy to visualize where each circle represents a batch. I can make the size represent the batch yield, and then I end up with 3 distinct clusters of batches with similar attributes. And based on the sizes, I can see this cluster has the majority of the high-yield batches. So selecting just this cluster and training a model, it creates a multivariate batch profile that I can think of as a golden batch, constructed from those high-performing batches. I want any future batches to stay within this target profile, ensuring the yield will be ideal. And this list in the bottom left shows the weight for the most impactful variables on batch performance. Any monitoring, advanced control, or process improvement initiatives should target these parameters first. Then I can plot any batches against this profile to see which ones I expect to have high yield. So this one looks good, whereas this one seems to be deviating at some points. I can look deeper into this using the univariate charts. I can also use some residual charts to help me easily identify where I'm deviating from my target, which also makes it easy to set up proactive alarms and alerts for when this occurs. And when deviations do happen, I can identify which specific parameters cause that deviation by checking local variable importance and how the variable weighting here differs from the base model. With a couple clicks, I can then deploy this as a real-time model to monitor more recent and current running batches. The toolset is largely the same as offline, only now this data is streaming in from the platform and will update in real time, enabling proactive monitoring. From here, we can build predictive models to project this batch performance into the future to the end of the batch run. And if we start seeing deviation from that ideal profile like we have here, we can even tie into Quartic's optimizer application to make setpoint recommendations for how to best correct this batch trajectory. Using the Quartic MVDA application, you can get better, more consistent yields, or any other metric important to your process: cycle times, purity, conversion, recovery rates, energy consumption. No more struggling with multiple tools, with scalability, or with cost. The Quartic MVDA tool is the modern solution to all your multivariate needs, from offline to real-time to predictive modeling. To learn more about how it can help with your specific process, or to schedule a more in-depth demo, reach out to us here at Quartic AI.